There's a technology that's been quietly reshaping the internet, and it promises a massive shift in how the web performs. It's called WebAssembly, and today we're going to dig into why it's such a game changer.
So let me ask you something. Imagine a web where those super complex applications, the ones you usually have to download, run just as smoothly as native desktop software, but right inside your browser. Well, that's the promise of WebAssembly, and we're about to break down exactly how it pulls it off.
But first, to really get where we're going, we need to understand the problem we're trying to solve. And that's the performance limit, the ceiling of the web as we know it today.
We have all been there, right? That little loading spinner that just won't stop. Or a web app that stutters every time you click. Your laptop fan starts screaming. These aren't just little annoyances. They're actually symptoms of a much deeper technical challenge. For decades, the engine of the interactive web has been JavaScript. And look, it's amazing. It's flexible, it's powerful, but for the really heavy, computationally intense stuff, I'm talking the kind of work desktop apps do without breaking a sweat, JavaScript can hit a wall. It just wasn't built for that kind of raw power. And this is where our story takes a really cool turn. To smash through that performance ceiling, a new technology showed up. Not as a replacement for JavaScript, but as a super-powered partner. So let's meet WebAssembly. Okay, so what in the world is WebAssembly, or Wasm for short? Well, think of it like a super-optimized, low-level language that browsers can understand incredibly fast. See, JavaScript is interpreted as it runs, but Wasm is already compiled. It's like giving the browser a pre-translated script it can execute at speeds that are, frankly, ridiculously close to native apps. Now this is a crucial point. Wasm isn't here to replace JavaScript. Not at all. It's here to supercharge it. Think of it this way. JavaScript is the director of the movie. It manages the user interface, the interactions, the whole show. Wasm is like the special effects team you bring in for the huge, explosive scenes that need raw, heavy-duty power. Together, they are an absolute dream team.
And one of the biggest wins with Wasm is that it just unlocked the web for a whole bunch of other programming languages. Now developers who are experts in super fast languages like C++, Rust, or Go can bring that expertise and that speed directly into the browser. It's a huge deal.
All right, so that's the theory, but what does all this new power actually look like out in the real world? Let's check it out. Oh, this is a big one. You know those incredibly complex, graphics-heavy 3D games? The ones that used to need a console or a high-end gaming PC? Well, now they can run smooth as silk right inside a browser tab. Wasm is what gives them that near-native speed to handle all the physics and rendering without even skipping a beat. Here's another mind-blowing example. Video editing software. These programs are famous for being resource hogs, right? But now they can run efficiently right on the web. Wasm is doing all the heavy lifting in the background, encoding, decoding, applying effects, making web-based creative tools just as powerful as the ones you install on your desktop. And believe it or not, Wasm is breaking out of the browser. Because it's so secure, efficient, and can run anywhere, people are starting to use it everywhere, from tiny Internet of Things devices to massive cloud servers. It's actually on its way to becoming a universal way to run code. So when you put all of these pieces together, you start to see that this isn't just some small improvement. It's really the beginning of a whole new way of thinking about what the web can even do. What it all boils down to is this. The line between web apps and the native software on your computer is getting blurrier and blurrier. Thanks to Wasm, we can get these rich, incredibly powerful experiences right in the browser, with no download, no installation. Just click and go.
And for the developers out there, the process is actually becoming pretty straightforward. You write the parts of your code that need to be blazingly fast in a language like C++ or Rust, you compile it into a tiny little .wasm file, and then you just call it from your JavaScript. It's a really clean and powerful workflow.
Now, as exciting as all this is, and it is very exciting, no technology is a magic wand. So to really get the full picture, we have to look at both the amazing future and, some of the challenges that are still there. This quote just perfectly captures how the developer community feels about this. It's not this loud, flashy takeover. It's a deep, fundamental shift that's quietly building steam, a silent revolution.
So let's be realistic for a second. The strengths are incredible, no doubt, but there are challenges. Sometimes those initial Wasm files can be a bit larger, which can affect load times.
and trying to debug it can be tricky because the tools aren't quite as mature as what we have for JavaScript. So yeah, it's incredibly powerful, but it's also still got some growing pains.
And that really brings us to the single most important takeaway here. You don't rewrite your entire website in WebAssembly. That's not the point. You use it like a surgical tool. It's the specialist you bring in for the most demanding performance-critical parts of your app, the parts that absolutely, positively have to be fast.
So, the performance bottlenecks that have kind of defined the web for a generation, they're starting to melt away. The power is now in the hands of developers and creators. And that leaves us with one final and really exciting question. The speed is here. So what are we going to build with it?